Okay, so let's run through how to prepare your data and make some column graphs. So here we've got our data. We're in the biomass tab here, and you can see the upper data set is the control plants and the lower one is the attached plants. There's 4 sets of data in each group. P plus H plus, P minus H plus, P plus H minus, and P minus H minus. So this of course refers to the phosphate supply to the parasite, which is either plus or minus, and the host, which is either plus or minus. For each set of data, we've got, for each group, we've got 2 columns. One is the PJ dry weight, that's the parasite, and then a T dry weight, and that's the host plant. Now we could plot these out as XY scatter plots, but unfortunately that won't be very good with so much data. It'll be very cluttered and hard to see patterns. And so I would recommend we use column graphs, and that's what we're going to do. So for each data set we want to calculate the mean value. So I'm just going to go into this cell here, B17, and I'm going to go equals average and open my parentheses and then grab that data, and that returns a mean of 108. And I'm going to calculate out the standard error. So there's 2 big measures we can use. One is the standard deviation, which tells us about the variability of the data, and the standard error, which tells us about how precisely we can estimate the mean value. And so to calculate this, we do equals stdev, and we grab our data, and we're going to divide this by the square root of the number of data points. Now we've got 12 plants there, so the square root of 12. And that gives us 11.2. So I can just drag this across. So down in the bottom corner there's a little square, and if you put your cursor over that, it will give you a cross. You can drag across, and so this is going to be our mean and our standard error. And then what we can do is we can just grab those and do copy and paste. Now you can either do right click and then copy, and then right click and paste, or you can do Control C if you're on a Windows machine. I think it's like Command C on a Mac, and then Control V in order to paste, and it will calculate those out for you. So we'll just do the attached plants as well. So what you can see is here for this first group, the mean for the PG is 108, and you can see for the attached PG it's 151, so it's about 40% bigger. We can see that the host plants 219 in the controls, 174 or 175 in the attached plants. So we can see they've got a little bit smaller. Now there should be some patterns in our data, but we want to turn this into a graph to help us visualize those. So what I'm going to make a little table up here, So we'll go P plus H plus P minus H plus P minus H plus P plus H minus, and then P minus H minus. Now what I'm going to do is I'm going to grab the mean values over here for the first group, and I'll just do Control and C, and I'm going to paste them up here. But when I do paste them, I want to do the right click on the mouse and do paste as values, and then they will stay the same. For the next group, if I just do Control C and Control V, it will give you an error because it will say it can't find the data. So you want to paste those as values, and this is our controls. We're just putting those all in 2 rows. This is just the parasites for now. We'll just type that up there, parasites. And these are the controls, so we'll just type control here, Control, and then that's the standard error. And then these are going to be the attached plants, or you can call them parasites or whatever. Oops. And we will just go through and do copy, and we'll just paste those in there. Let's just zoom out a little bit, and we can just copy and paste, copy, paste, copy and paste. Okay, so we're ready to make a graph at this point. So what I'm going to do is I'm going to grab from this Q4 cell. Okay, so it's the one just right up in the corner, and I'm just going to grab and highlight along like this, just the first row of data, just the means. And in the insert menu, I can go to this column chart, and I just want to choose the first one. It'll say clustered column, and if I click on that, it'll give me a graph. It's got these values here. You can see the y-axis just goes from 103 to 110, but that will change when we add in our second data set. So let's just do that. So if we right click on the graph, then there's this option here, select data. Click on that and it'll bring up a dialog box, and this will ask us, it's got the first data set in there. It says control, and if we add a new series, first of all it will ask for a name. So I'm just going to click on that attachment box over there, and then the series values are going to be those ones, 151 through 230, and just go OK. We just highlight those, and you can see it's added the bars in already, so we can just go OK. Now for the x-axis, we can actually see, if we look at the graph, you can see it's already added the names. That was because we highlighted them at the start, but otherwise we can edit them in this button over here, and we can tell it those are the names of our groups. It already knows this, but that's okay as well. You can also type them out if you really want to, and we'll just go OK and OK. So we've got a reasonable graph here, but we're going to want to add on some error bars. and we're also going to want to fix those axes to make them a little bit more pretty, a little bit more informative. So first of all, let's put on some error bars. So if we're clicked into the graph, we can go up to the top here. There's a chart design, and there's a button over on the left side which says add chart element. If we click on that, you can see there's lots of options here, and we want to go into error bars, and the one we want to choose is actually greyed out at the moment. It's more error bar options. So I'm going to go and click on the data series I want, which is the blue one here, and go back into that error bars one, and you can see now it's available more error bar options, and that will bring up a dialog box on the right side of the chart, or your Excel spreadsheet. And it will give you various options. First of all is for changing the direction of your bar. You can make them plus only, or minus only, or both. You can get rid of the little caps on the top. Now at the moment it is set as a fixed value. Now we don't want a fixed value, we actually want a custom value, because we've actually calculated out those standard errors there. So I'm going to go down to the custom one and click on this specify value box. And now what I can do is I can grab those standard errors that we already calculated out and go OK. And it will add those standard error bars there. And then we can do the same for the other data set, the attached plants. So just going to add chart element and then error bars and more error bar options. Go to this little one that looks like the bar graph here, and then go down custom, specify values, and we can just grab those values there. We can go OK, OK. So we've got our error bars there. I would probably make them a little bit thicker. I go over to this little paint can here, and in here you can change the width of those. I'm going to change the width to 3 points, and I'll do the same for these ones. I'll just change that up to 3 points. It makes it just a little bit easier to see them. We also want a y-axis, so again we're going to go back to this add chart element and go axis titles and go to the primary vertical one. And it gives us a new box which says axis title. We can just double click in there, or just click into that, and we can give it a name which is going to be something like parasite mass milligrams, or we'll call it P. japonicum mass, because some of them are not parasites. Maybe I want to highlight that P. japonicum there, and then do Control I to make it italics. I'm going to get rid of these grid lines. I don't really like that. I also would like to change the gradation on this y-axis. Now it's 0, 50, 100, 150, 200. And I'm going to change that due to major units. I'm going to go over to the major units here and change it to 100. And that just makes it a little bit more nicely spaced out. I may also want to change the text size. Some of the text is a little bit small, a little bit hard to see. So I can just go into the home menu here, click on the graph, go into the home menu, and I can change the size of the text here. I'm not sure why this is kind of zooming in and out a little bit. when I do this. Anyway, I can change those a little bit. It seems to have got rid of the italics, I think, there. Okay. One more thing I'll do is I'm going to just remove the, click on Format Chart area. I'm going to take away the border. So there's no line around this, which makes it a little bit prettier when you copy and paste it into Microsoft Word. So what can we see? First of all, the attached plants tend to be a little bit larger. They're larger in all cases, but we can see also when it's P minus, these orange bars tend to be much bigger. So they're a little bit bigger in the P plus, but in the P minus they're much larger. Now of course you could do the same thing for the hosts. You copy this table, delete out the data, and you could make a second graph here for the host plants, and then you could see what happened to them. Okay, so on the second tab it says it's got the nutrients. We can see the data is set up in the same way, except here it's got nitrogen concentration, phosphate concentration, and then the 15N atom percent abundance. Now we'll just deal with the concentrations first. So let's just calculate out the mean and standard deviations as we did before. Standard errors. So that's going to be the standard deviation divided by the square root of the number of samples, which is 12. So that's going to be mean and standard error. And we can drag that along. Now we'll just drag it along to this 15%, 15N atom percent abundance here. I'm going to just expand the number out a little bit. There's this little number menu up here. You can just give it some more decimal places. We'll just copy that and paste it for each group, just as we did before. Now even a fairly simple look, fairly superficial look, you'll see that the mean N concentration tends to be higher in the attached plants relative to the controls, and the phosphate concentration tends to be a little bit lower in the minus P treatments relative to the P plus or the phosphate plus treatments. Phosphate concentrations tend to also be a little bit higher in the attached plants. But again, you'd want to make a graph and look for patterns. Okay, how about this 15N atom percent abundance? So let's just have a look at this graphic. Here we've got a hypothetical plant. It has a mass of 100 milligrams. If the plant has a nitrogen concentration of 5%, then it would contain 5 milligrams of nitrogen. 100 milligrams of plant multiplied by 0.05, that gives you 5 milligrams. So the nitrogen in here is, the whole plant is 100 milligrams, the nitrogen is 5 milligrams. Now of that nitrogen, some is going to be 15N, and in this case the 15N is going to be 10 atom percent. So 10% of this nitrogen will be 15N. So we take the 5 milligrams we already calculated, and multiply it by 0.1, okay, which is 10%, and that would tell us that this plant contains 0.5 milligrams of 15N, which of course is 500 micrograms. So this is fundamentally how to understand about 15N atom percent abundance. Now there's one other thing I should tell you, which is that there's this thing called natural abundance. Now 15N is an isotope. We make it in a cyclotron, but it also exists in nature, and its natural abundance is 0.3663 atom percent. That's what you'd expect to find in nature just as a background, even if we don't do anything. So we're going to have to subtract that from what we actually have. I'm just going to pull this down here just so it's kind of out the way. You can see here, if we look at the 15N atom percent abundance for the controls, you can see it's actually always right about that 0.3663. So they're almost identical to natural abundance, but we're gonna correct for this. So what I'm going to do here is I'm just going to grab these this column up here, or this row up here. I'm just going to copy it and paste it over here, and I'm going to keep that spacing exactly the same, and you'll see why in a little second. So the first thing I'm going to do is I'm going to calculate out the nitrogen content, okay, and that's going to be in milligrams. So we know our nitrogen concentration there, which is in percentage. So I'm going to open some parentheses, and I'm going to take this 3.14 and divide that by 100. Now I need to multiply that by the plant mass. Now the plant mass I'm going to find in the biomass tab. So if I just go multiplied by, and then go down to the biomass tab, and then click on the first plant here, this 140.1, I can press enter, and it will calculate out that there's 4.4 milligrams of nitrogen in that plant. Now the spacing is identical between the two groups, and the data structure is the same. So these plants here are the same as these nitrogen concentrations here. So if I calculate out that first one, then I can just drag down and it will calculate out that whole row. And if I grab this, just copy all of that and go over here to the next column, and then just press paste, and then paste here and here, it will calculate out, it will find the right values. Okay, so if we just go into this second one here, so now it's calculating out this F3 multiplied by biomass F4. So let's just find out what's biomass F4. Biomass F4 is this cell here. So because our data is very structured, then we can, it makes our calculations much easier. And we can do the same thing for the attached plants as well. We can just go in there and just copy and paste. Slightly got that position wrong there. Okay. Now for each of these, of course, we can calculate out the average. And the standard deviation, a standard error. Square root of 12. And we can just copy and paste that out, and you should see all the controls are pretty similar. They should be essentially identical, and our treatment plants are a bit different to the controls and to each other. So you'll need to think about why that is. Now this is how much nitrogen the plant contains, but we're also interested in how much 15N it contains. But we've got this kind of pesky natural abundance. So what we're going to want to do is we're going to want to go into this cell. We'll just put this in as 15N micrograms. So we'll do this calculation in kind of steps. So first of all, let's just do equals, and I'm going to open some parentheses, and I'm going to take this first column here, this D3, and I'm going to take away 0.3663%. And so this is the measured percentage minus the natural abundance, and so this is what we call the enrichment, and in this case it's a very small number, but this is a percentage still, and so if we want to use this value, we're going to have to divide it by 100, and it's became a much smaller number. So this is a percentage, but in order to use it, we need to divide it by 100. What we're then going to do is I'm just going to wrap this all up together, and I'm going to multiply it by the number of milligrams of nitrogen by the nitrogen content, which we calculated there. So let's just multiply by the nitrogen content. So this is now giving us 15N in milligrams, but these are going to be very small numbers, and so I'm going to turn that into micrograms. So I'm going to multiply all of this by 1000, and I'm going to put the formulas up at the bottom of the screen so that this hopefully is understandable. So we've done that for the first one. We've calculated out the enrichment, or the amount of micrograms of, sorry, that should be micrograms now. We just multiplied by 1000. So let's just drag that down. Now for these controls, they should be all kind of around about 0, and we can just copy and paste. We can do the same thing for the treatments, for the attached plants. You can see those attached values are much larger, and we can just drag across those means and standard errors. So they should be almost 0 for the controls, and for the treatment ones they're going to be quite a bit larger. And you can think about why they'd be larger and what that might mean, what that's kind of suggesting about our system. And so of course what you would want to do is you then want to go out and make some graphs which show all of this data, what's happening in each group. So you might not want to make graphs for everything, but I'd probably make them for the nitrogen concentration and the phosphate concentration, and probably for the 15N content. But I probably wouldn't do the nitrogen content, probably just the 15N content. So if it was me, you'll have two biomass graphs, this one and then one for the hosts. And then you'd have one graph for the nitrogen concentration, one for the phosphate concentration, and one for these 15N contents. So that's 15N content, and that's in micrograms. So that's probably how I would do that. And next week we will look at doing some statistical analysis of this. But for now, let's plot out some graphs and see what story the data is telling us. Okay, that'll do for now.